Let's take this another problem from the same chapter of Newton's law of motion. Tells that find the reading of the spring balance. So here is the spring balance that you can see, as shown in the figure. The elevator is going up with an acceleration of g by 10. That means the whole elevator is going up with an acceleration of 10. Let us consider this acceleration is, let us consider this acceleration is zero. Now, tension here is T. This tension will be actually the weight shown by the spring balance. If the tension here is T, then the tension here is obviously T by the tension is obviously T by 2. Total tension is divided by the two things. And in order to start to solve the problem, let us consider this 1.5 kg body as a free body. We write this way, take 1.5 kg. Take 1.5 kg body is a free body. Then what is the diagram of it? This 1.5 kg body has got a downward force of mg. mg is, m is 1.5, it has given. And it has got a upward tension of T by 2. Must also observe one thing, that is, consider the lift is fixed. It is not going up or going down. Even in that case, this is 1.5 kg and this is 3 kg. So these bodies will start moving in this direction. That means 1.5 kg body will go upward, a 3 kg body will go down. Their motion, acceleration, or speed will be identical. Let us say this acceleration is A1, and let us say this acceleration is also A1. So this body is going up with an acceleration A1, and the whole body along with the lift is going up with an acceleration A0. Right? So if we write the equation of laws of motion of these, the force equations, we find the force equations is T by 2 because it is going upward. So T by 2 minus downward force is mg, which is m is 1.5, is equal to, it has got two accelerations upward, A0 plus A1, and this multiplied by m, where m is 1.5. So from here we get multiplying it by multiplied by 2, then t, m is 1.5, so t minus, it will become t minus 3g is equal to, again, this m is 1.5, which will be multiplied by 2. This is 3 within bracket A0 plus A1. Let us say this equation is equation A. Similarly, if you take the free body of the kg mass, then its diagram is like this. This is 3 kg. The downward force is 3g. Upward force is d by 2. And it has got a downward acceleration of a1 and an upward acceleration of a0. So for the second body, right, for the second body, the equation is t by 2 is equal to t by 2, not equal to, right? Second body, t by 2 minus 3g minus 3g by 2 minus 3g equal to, yeah, it will be equal to a0 minus a1. a0 minus a1. Again here, if we multiply it by 2 from both sides, it becomes t minus 6g is equal to, this will be multiplied by 3 because it is ma. This will be multiplied by 2 again, so it will be 6 into a0 minus a1. Let us say this is equation. Solve this equation A and equation B. Find that tension T is equal to 22 pi by, and T is the tension which is experienced or felt by the spring balance. So the spring balance so now let's go to the next problem. The next problem, it shows that in a simple Atwood machine, two unequal masses of 300 gram and 600 gram are connected in a string over a clamped light smooth spool. Here, once again, if this tension, consider this tension as tension is also T. This tension is 2T. And both of them will have both this and this will have both these two will have the same acceleration. Let us say this acceleration is a0, upward. Of course, this is lighter, it is upward. This is a heavier body, acceleration a0. And for the sake of understanding, let us consider this is body A. Let us consider this is body B. Then, taking the free body, taking A as taking A as the free body, it is going upward, and its upward force is T, upward T minus downward force is 0.3 g. 300 gram is 0.3 kg. So 0.3 G equal to 0.3 M into A0. 0. And similarly, taking B as the free body, this downward force, it is going downward. So here downward force is 0.6 G minus T. Its downward acceleration is A0, mass is 0.6 equal to 0.6 H. We solve these two equations. We can easily solve this. We will find A0 is equal to 3. That means the body A is going up and body B is going down, both with an acceleration g by 3. Now the question which was asked, find the distance traveled by the first block in first 2 seconds. So now we can use the equation of the kinematics, where distance S is given by equation ut plus half alpha for acceleration t square, and we have to find out the distance traveled by first 2 seconds, and initial velocity is 0 plus half, acceleration is g by 3 square is equal to 4. This distance you will find, this distance you will find 6.5. Distance we will find is 6.5 meter. So this is one answer, 6.5 meter. Second question is, find the tension in the string. So since A0 is known by 3, so from any one of the equation you can find out T. So if you, this I am not doing because this is unnecessary deduction, will take a lot of time. T you will find 3.92 meter. Because A0 is known, so from any this equation or this equation, you put the value of A0, you will find the tension T. T is 3.92 meter. This is also found. Next question is, find the force exerted by the clamp on the pulley. The force exerted by the clamp is 2T. So this is answer A, this is answer B, answer C is force exerted .84. Other answer 7.84 meter. As the last question, if the larger mass is stuck for a moment, 2 seconds after the system is set into motion, find the time elapsed before the string is tight again. This question needs a little bit of understanding. This question needs a little bit of understanding what the question really says. Let us say this one block was here and another block was here. They were head over a pulley, and this is going up and this is going down. When it goes down, down, down. After 2 seconds, so this time elapsed here is 2 seconds. After 2 seconds, it is suddenly blocked. It is suddenly blocked. Then what will happen? Will the body A also stop? No. the body A had an initial acceleration A0. So it continued to move upward, and like the string will be slack and it will continue to move upward. Body A will continue to move upward. But how long? Since the string is slack, there is no upward tension. The body will move upward and it will come to zero velocity at some point. When it comes to zero velocity at some point, suddenly, once again, it will drop down and the string will become tighter. So we just have to find out what is this height before it comes to zero. This now it's not very difficult. So this body air is moving upward. Its speed is have to find out. It has a u. That means from starting after 2 seconds, what is its velocity? We will find out. And its final velocity v will be zero. Final velocity v will be zero. So let's find out what is the u. That means what is the velocity of these blocks in 2 seconds when it starts with an acceleration a0, which is equal to g by 3. And once again find out this one. Let us say this velocity is v is equal to, once again by the ut plus, I'm sorry, v equal to u plus a. This is equal to initial velocity was 0, a was g by 3, 3 t is 2 seconds, that is equal to 2 g by 3 meter per second. That means this u is equal to 2g by 3 meter. But to find out, we have to find out that how much time, find the time, how much time it takes to reach to the velocity 0. That is, once again, it is use the same formula. Final velocity is 0. This velocity is, initial velocity is 2g by 3 minus, when it goes up like this, it goes against the gravitational force g into t. From this here, you can find out t. So, what will happen? Once the downward falling block is suddenly stopped after 2 seconds, and in these 2 seconds, both this one has a velocity of equal to 3 by 3. This one also has velocity of 2g by 3, but it has suddenly stopped. So this will continue to fly upward against the gravity with an acceleration a0. And with this acceleration is a0, it will go up by another 2/3 second before it stops going up, and then it will suddenly fall. So this is the problem. Now let's go to another simple problem. This problem says, consider the situation shown in figure. This is the figure. Find the magnitudes of acceleration of the two blocks. Now, these are the two blocks. One is 1 kg, and this one is also 1 kg. So which one will go up or which one will go down, or both of them will remain static? Here, like all problems, you have to apply a little bit of your mind. Here, On the left-hand side, the slope is high. So obviously, this block will go down and this block will go up. This block will go up. And this is the acceleration A, say. This is, say, the acceleration A. And this is also acceleration A. So we have to only find out, and both accelerations are same. We have to only find out the magnitude of this acceleration. Direction they have not asked. Of course, both the directions, they are neither vertical nor horizontal, they're inclined. So what do you do? Say, let's once again name them. Let's name them the body A, and this is body. And then let us say this is body A. Let us say this is body A, which is on a inclined plane, It is on an inclined plane. Now diagnose the forces acting on it. The force acting on this is force of mg. And let's say this angle is theta. And the acceleration is in this direction. This is A. And tension is in this direction. This is tension T. So we have to only find out what is the amount of or magnitude of mg in the direction of A. The magnitude of mg in the direction of A, in mg we find the two components of mg, one in this direction, another is in normal direction. This value is mg sine theta 1. Say this is theta 1, mg sine theta 1. Right? So now apply the force equation. This is going downward. So the downward forces are mg sine theta 1, mg sine theta 1 minus the inclined upward force T is equal to its acceleration, its mass m into acceleration A. This is one equation, so equation A. Right? Similarly, let us consider the other body. Also on an inclined plane, and let's say this mass, and this is downward gravitational force of it, mg, and the component of mg in this direction is mg sine theta 2. Let's say this angle is theta 2, and there is an inclined upward force of T. So from this we get, and this is going upward, and this body is going upward with an acceleration. So you can once again write this equation, T minus mg sine theta 2 is equal to ma. In both cases, we have taken m because given in both cases, the value of the masses are 1. So let's say this is equation B. From equation A, we find that, or we'll do one thing, equation A will do equation A plus equation B. And if we add equation A and equation B, find mg, this t and plus t and minus t will get cancelled. So mg sine theta 1 minus mg sine theta 2, mg sine theta 1 minus equal to ma and ma both together is 2 ma. Now what is sine theta 1 and sine theta 2? This is, we've taken theta 1, we have taken this one as theta 2. Obviously, we'll find sine theta 1 is equal to 4 by 5 and sine theta 2 is equal to, here this m and m gets cancelled. From here, you can easily find acceleration is equal to g by. That is the question of find the magnitude of the acceleration of the blocks. The acceleration is g by 10. So let's stop here today. Next day we shall continue another few examples.